We are 1 minute from entry interface.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your jet data flow.
About seconds from entry interface. 5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars. We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. The spacecraft is now waiting until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost lock.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Yes.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes. Yes. Yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Almost there.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Yes.
We have priming of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
As expected. As expected.
Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.
All right, all stations.
We got it. We're
Touchdown
there.
confirmed. We're going to wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
So much has been riding on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not
Flight, we have seen the completion of EDL 3000. Copy activity. That is as expected.
MRO is still seeing a strong signal from the lander.
Był projektowany y
We have just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
Flight, this is OL3. I have the target point on the map when you are ready.
We are ready, OL3. Go for it.
Flight, I'll be moving in, showing you the safe zone that we've landed in.
Just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
This is amazing.
Where's Andrew?
For Steve. Stand by for Steve.
You did it. You did it. You did. You led the team. You made it happen. Congratulations.
We just got our second image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. You can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what to do these kinds of things and make success happen.
Yeah.
And joining us now is the acting administrator of NASA, Steve Jurczyk. Steve, welcome and congratulations.
Hey, thank you. What an amazing day.
How does it feel to have another rover on Mars?
It's amazing to have Perseverance join Curiosity on Mars, and what a just a great Perseverance.
And this and this is the most
to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every new thing is the Ingenuity helicopter. It's an experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions. And then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars. And then for human exploration, we have the Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade, and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions, or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2, and that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech demo on Perseverance. And then we're going to continue to characterize the frozen water on and below the surface of Mars, and eventually try to figure out how to extract that water from the Martian soil, or what we call regolith, and then we can use that for potable water and also break it down into oxygen and hydrogen for rocket fuel. So absolutely, we're going to try to eventually figure out how to live off the land to support human missions to Mars.
Thanks for taking the time to talk to us today, Steve.
Thank you.
And now that Perseverance has safely touched down on Mars, let's learn more about what's in store for the rover. Joining us now is Surface Mission Manager Jessica Samuels. Jessica, your surface operations team has now taken over. What are they doing now?
Yes. Hi, Raquel. We are so excited here in the Surface Mission Support area. The team will do a handover with the Entry, Descent, and Landing team and pass any critical information. And then this team behind us will be the team that does the health and safety assessments daily as we progress on this mission.
And what do the upcoming weeks look like for your team?
So as we enter Mars time now, the commanding team will be working overnight while the rover is asleep so that we can perform the initial checkouts of our key rover functions and our science instruments. And we have to do this all in time for the regularly scheduled communication pass, which happens in the morning. And so we will be working around the clock, making sure that Perseverance is healthy, and we will begin this exciting adventure.
And can you tell me, what's it like living on Mars time?
It's a little bit like constantly, flying and changing your time zone. The rover, on Earth, the rover wakes up at the same time every day, but on Earth, that's 40 minutes later. So the team is going to be shifting our work schedule by 40 minutes as we come into work over the next few weeks. So it'll be exciting and some late nights, but we're also excited and we can't wait.
It's a whole new lifestyle.
Yes.
We also have a student question for you. This is Sophia's video.
Hi, my name is Sophia Lopez, and my question for NASA is, how's Perseverance gonna survive? And here's a drawing that I made from Perseverance thinking about Earth. Thank you.
Well, Sophia, Perseverance survives with a power source that charges its batteries overnight while it sleeps, and it keeps heaters on so that all of our critical electronics can stay warm, as well as our mechanism. But it's really survived by the team that performs the health and safety assessments every day and communicates with the rover and makes sure that she's doing okay.
Well, thanks for your time, Jessica, and good luck living on Mars time.
Thank you. Should be fun.
Let's head back to Marina as she gives us a sneak peek into the future at JPL.
Thanks so much, Raquel. It's definitely bustling behind me. It's not quiet like it was just 20 minutes ago. And congrats to the whole team. What an amazing accomplishment. Mike Watkins is the director of NASA's Jet Propulsion Laboratory. He was the mission manager during the Curiosity rover landing on Mars. Welcome, Mike.
Oh, thanks. Glad to be here. You can see all my mask markings on.
Well, you were just celebrating, and rightly so. Now, you've been around for a number of Mars landings. What makes this one special?
Well, you know, two things. I mean, it's the biggest and best rover we've ever sent to Mars, and it can really, you know, do amazing things in terms of, you know, its own scientific exploration of this habitable environment, you know, at Jezero. But, you know, it's also, as you've heard today, you know, it's the first step in Mars sample return. So really, you know, it's not only doing its own mission, it's setting us up for a series of missions and to bring those samples back. And, you know, a lot of the effort to develop the rover was specifically designed, you know, for that sampling and caching system. It's one of the most complex robotic systems ever made. And, you know, having it down safely means Mars sample return continues right on course, and we are moving forward.
Wonderful. Now, JPL
It's extremely difficult to fly at Mars because the atmosphere is so thin compared to Earth. At Mars, it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure to return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it will fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight tests at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle is performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Mimi Ong is the project manager for Ingenuity. She joins us now as they await a chance to check out their helicopter in the coming days. Welcome, Mimi.
Thank you, Marina.
Oh my goodness, we've been talking about this for months, Mimi. Did you ever think you'd be here at this point? I mean, what's going on in your head right now?
This is super exciting. We have been working on Mars helicopter for over 6 years, testing and carefully designing it for operation at Mars. So what's going through my mind? Ingenuity Mars helicopter is finally at the destination that it is designed for.
Now that Ingenuity is on Mars, what is the timeline you hope to accomplish as you move forward?
We have a series of major milestones between now and Ingenuity's first flight. So tomorrow we'll turn on the helicopter,